Hello everyone, we will discuss problem D for the round 879, and I solved it quite late in the contest. So what does the problem say? Basically you're given n students and you are given m subjects, and each student knows subjects from some range Li to Ri. Now there's a teacher and the teacher will ask a set of topics from between 1 to m, and she can ask 0 topics as well, 1 topics as well, any number of topics, but each topic can be asked or at most once. For example, she can ask the topics 4, 6 and 8, or 1, 3, anything. What will happen when she asks a topic is that all the students who uh, know that topic, so for example, if we look at maybe topic 4, so in this case all the students know topic 4, so they will raise their hands. So initially their hand is at height 0. If they raise it, that it goes to height 1. But suppose we took this topic 8. She asked topic 8. So what will happen is that all the students, this student doesn't know the topic, this student doesn't know the topic, and this doesn't know the topic. But this student does. So he will raise his hand, his height will increase by 1, and the other's height will decrease. So it will like decrease by 1. So it will uh, increase by -1. Okay, and the heights can be negative as well. So the teacher wants to ask a set of queries such that in the end, what happens is the difference between the maximum height and the minimum height at the end of two different students is maximized. So this thing you want to maximize, and you can go through the test case to look like we can go through this test case. So if this is the LI and RI for 4 students, and the teacher asks these 4 topics 5, 6, 7 and 8. 5, 6, 7 and 8. So what will happen is that this student knows all of these 4 topics, so his height will become +4. But if we look at uh, fourth student, so if we look at the fourth student, he only knows topic 5, and he doesn't know topic 6, 7 or 8. So his height will be -2. Why -2? Because this will when topic 5 is asked, his height will come +1. Then here -1, -1, -1, 3 times. So -2. And the difference, uh, you can also calculate the heights for these students, but this difference will be maximized. So 4 minus -2 is 6. So the answer for this test case is 6. So now how do you solve the problem? First, let's look at how do you solve it in a brute force manner, and then we will optimize it. Okay. So suppose we have some students, and we sort the students based on the LI-RI pair. Okay. So we sort the students based on this LI and RI based on increasing LI basically. So suppose the first students after sorting look something like this. Okay. The second student looks something like this, like his Li is after this Li. The third student may look something like this, and the fourth student could look something like this. Okay, so this is the first student, this is the second, this is the third, and this is the fourth. So for a brute force solution, what you can do is you can iterate over all pairs of students. Okay, and you can assume that okay, suppose this is student 1 and this is student 2 that you are iterating over. You can assume that this will be the minimum and this will be the maximum. Just assume, okay, that in the end, after asking a series of questions, this student has the maximum height and this student has the minimum height out of all the other students. Okay, so basically, when you fix these two, then you will try to find the optimal questions that you must ask. So I will give you an example. Okay, Suppose we look at student 1 and student 4. Okay, this is student 1 and this is student 4. As you can see, both of their ranges are completely disjoint. Okay, if we are assuming that student 1 is the minimum and student 2 is the maximum, so what questions should we ask? We should obviously ask only these questions. Why? Because when we ask these questions, um, this student's height will increase. It will keep on increasing per question, and this student's height, it will keep on decreasing. Okay. If we ask any other question, suppose we ask a question somewhere here, which is not lying in both of these ranges, then what will happen? Both of their height will decrease by 1, and the absolute difference will not change. So the absolute difference is score 1, score 2 minus score 1, right? So if both of these are subtracted by 1, then the difference doesn't change. Or if you, instead of asking a question in this range, like I said, we will ask only these questions because we are assuming this to be the maximum. But if you say no, I will ask a question here which lies in this range, which is which lies in the set of topics known by the first student. So what will happen is this will decrease because this guy doesn't know this topic, but this will increase. Okay, so suppose initially the score was initially the height was 0 0. So what will be the new height? The new height will basically, for this student it will increase, and for this student it will decrease. Okay, and then this won't be the like this won't really be the maximum. So in such a case, when we are considering two students who are disjoint, who don't know any common questions, then it is either optimal to ask only these questions or only these questions. Okay, but like one of this set, and in this case the answer would be, suppose this is Li, this is Ri, this is suppose Lj and Rj. So suppose you only ask these questions. Okay, so what will happen is every time you ask a question, this guy's score will increase by +1 and this guy's score will decrease by -1. So the final score will be 2 times Rj minus Lj plus 1. Or if you had only asked questions in this range, okay, then the score would be 2 times Ri minus Li plus 1. Please note that we are only considering two students right now. We are not concerned about the others. We are assuming that one of these will be the minimum and one of these will be the maximum. Others we are not concerned about. If some other uh, if some other pair of students have a better answer, then that will be found out eventually because we are looking at all the pairs. So for disjoint sets, this is going to be the answer. Okay, maximum of these two. So you will either ask only these questions or you will either ask only these questions. You will not do something like you will ask a question here and also a question here, because then it's useless. If you're asking a question here, then ask all the questions from this range only. If you're asking question here, then ask all questions from this range only. So that's why for both the cases we have sort of taken the maximum. So this is the first part of the solution, when the students have um, disjoint ranges. Now, how will you implement this case in your solution? What you will do is, since you have sorted all the students, right? You have sorted all the students. So you will iterate over from I equals to 1 to n. You will iterate over all the pairs. So suppose you are at this particular pair. Okay. You will, since the segments are sorted based on L, right? So the previous segment could have looked something like this. The segment before that could have looked something like this. So suppose this is 0, this is 1. This is the ith, I equals to 2s segment. The third segment would definitely start after this point. So it could be like something like this. The fourth segment could be something like this. The fifth segment could be something like this. And sixth segment suppose is something like this. Beyond this point, so since this is the first disjoint segment, it is starting after this segment is ending. All the segments after this will also be disjoint. Okay. So what you can do is you can, for each I, you can first binary search to find the first disjoint range to your right. And then what you can do is you can just make answer is equals to maximum of. So you're assuming this to be one student and another disjoint student will be somewhere from here, some range from this region. So if this is one of the students, then the answer is like this value will be 2 times Ri minus Li plus 1, comma 2 times whatever is the maximum segment size in this region. So I hope you're understanding why I'm talking about the, like this can be paired with many segments, right? But since the answer is the maximum, we are only it's like optimal to only consider the segment of maximum length. Suppose this is a very large segment. So out of all these segments in this region, in this range, whatever segment has the maximum size, so maximum of uh, j, like maximum of j to n minus 1. Okay, so this is the first part of your answer, and this you can compute in order n log n. And how would you do it? It's very simple. Just sort the array. Then for each index, binary search to find the first disjoint partition. And then in this range, you want to find the maxima of sizes. So there are multiple ways to do it. You can create a prefix maximum array, sorry, suffix maximum, not prefix, suffix maximum. Or you can also use a segment tree to do a range query uh, in this region of the sizes or something like that. So this is the first part, and I will show you this part first in my code, and then we'll move on to the other parts as well. So we'll just look at what is important. So PNE actually is the it's something like prefix. I don't remember the definition now, but it is in the it's actually the suffix array of maximum sizes. So I fill it in reverse. So this is the uh, basically the size of the ith segment, and then I do um, PNE of I equals to maximum of PNE of I or PNE of I plus 1. So this is the suffix maximum size array. Then for the first part, like I'm doing binary search, so I go over each index. I set the start to be I plus 1 and to be n minus 1. And then I find the, basically I try to find the first index such that uh, the starting of that index is greater than the ending of yours. So uh, if you, this is you want to find an index, the first index which starts after you. So once you find that index, you simply do answer is equals to maximum of answer comma 2 times I have done at the end, so I have not written it here, but your current size and whatever is the maximum size of the suffix range. Okay, this is the first case. Now the second case. Basically, there are 3 to 4 cases to consider here. Suppose this is you. Okay, this is you, and we have talked about what we have talked about the completely disjoint case. Now let's talk about the partially overlapping case. So suppose this is you and this is another range, right? You are considering, now let's assume that you are considering this to be the maximum, or let me do it in blue color only, maximum, and this to be the minimum. Okay. So what questions should you ask in this case? Well, if you ask any question, see, if you ask any question which doesn't lie, which lies here or here, it won't make a difference because both of, uh, suppose this is student one, this is student two, so both of their heights will reduce. So, and if you ask a question in this common range, then both of them have studied this range, so both of their heights will increase. So the relative difference won't increase. So you actually want to find only, you only want to ask these questions. Okay. Now, for this segment, um, let me draw it here. For this segment, there will be multiple overlapping segments. So there could be a segment like this, there could be a segment like this, another segment like this, and then after a point there will be some disjoint segments. Okay, this region we have found by binary search. So basically, all the segments from I plus 1 to this idx, suppose this is idx minus 1, all these segments either lie inside this range or partially overlap. Okay, so out of all of these, since we want to maximize, we are assuming this to be the maximum. Since we want to maximize the height, we basically want to maximize this region. So how can we maximize it? We can maximize it by making sure that this other segment starts as far as possible. So, um, for example, this segment, if you compare this segment and this segment, right? This segment starts. It is obviously um, here partially overlapping, and this segment is also partially overlapping. So both of their endpoints are to its right. So this range is like completely gone. But in for this segment, only this smaller range is gone. So there is like more free space here. So what we want is from I plus 1 to idx minus 1, we want to find the segment with the farthest endpoint. Okay. And then our answer will be max of answer, comma, 2 times. 2 time will always be there because you will increase and the other guy will decrease. So the difference is increasing by 2 every time. And whatever is this empty space. So, it would be segment of k dot uh, ff minus segment of I dot ff. Yeah, this will be the thing. So what is k? K is in this range, in the overlapping, partially overlapping or fully overlapping range. K is simply the range which has the farthest starting point. Because like I said, if this is your I and you're assuming yourself to be maximum, and then there are multiple ranges, suppose this is one range and this is one range and this is one range, and there can be some ranges which are partially overlapping as well, but we will handle that separately, so it won't impact our answer if we do something like this. So if we consider this range and this range, then this much will be the uh, score that we can add. If we consider, because we can ask these many questions, these many questions are known by this blue line but not by the red segment. If we consider uh, this and this, then there are a more number of questions that you can ask. So you basically have to find the segment uh, with the farthest endpoint. And if you actually think about it, that segment would be nothing but the ranges are sorted by the start, so that segment will be nothing but the point just like idx minus 1. That will be the value of k. Okay, so that is the second case. I will show it to you. I have done it a little differently, um, but this will work. Uh, you can again, but in this case, yeah, this will work fine. Just find IDX. You just need to handle the case when IDX is equal to n. That means like there is no disjoint range. So this equation will also work. Now, what is the third case? Third case is also similar to the second case only. And in that, what we are doing is we are assuming that we're looking at this ith range. And previously, we assumed that this was the maximum. Okay. Let us assume that it is overlapping with some other range. Okay. We have handled the disjoint case before. And like, so I hope that is clear. And in this case, we will assume that we are the minimum and this guy is the maximum. All right. We are the minimum and the other guy is the maximum. So in that case, what questions should we ask? We should ask these set of questions which are known by him but not by us. And since we want to maximize um, this range, we what is this length? This length will be equal to endpoint of this range minus endpoint of our range. So E2 minus E1. Okay. Since I is fixed, E1 is going to be fixed. We want to maximize this segment. So we want to now maximize E2. So from I plus 1 to IDX minus 1, which are a set of overlapping ranges partially or fully, find the maximum range with the maximum endpoint. And for this, you will need to use like I used the segment tree. Um, and just simply you will update the segment tree with the endpoints and you can query for the maximum. So I will show you the code for this part now. Yeah. So what I have done is I have just queried from I plus 1 to IDX minus 1 and um, based on that query answer, just the empty space will be the endpoint minus my endpoint. Okay. And this is just a case to make sure that uh, like it might be possible that there is no overlapping range. Uh, so this handles that. This is just a check for that. Now the fourth last possibility is you may ask that okay there is last case possible of full overlap. So suppose this is the ith range and there is a range starting here which is fully covered by this ith range. Okay. Previously in the third and second case we had either taken this region like uh, like to the right of the overlap or um, we had taken like this region, right? So which is to the left of the overlap. But if the two ranges are completely overlapping, uh, what will be the region what will be the question that you will ask? You will ask questions in this range and in this range. Okay. So you cannot do something like subtract the endpoint because if we had subtracted the endpoint, then we would either get this range only or this range only. But we want um, we want to add both of them. So what are these how do you calculate this? This is basically the size of the ith range minus size of the jth range. Okay. And and now you may ask that we don't really know what all like this formula is for this overlapping case only, right? But we just cannot even if we sort based on the starting indexes, it is possible that this range is overlapping, but there is a range like this which is not overlapping, right? So there is no continuous segment of fully overlapping ranges. but it won't really matter. So I will first tell you what you have to do. Um, Basically, if like from I plus 1 to idx minus 1, what you can do is size of I is fixed, size of j is not fixed. So you want to minimize size of j. So you will do a min query on size of j in this range. Even if you do it in the range of I plus 1 to n minus 1, it will not impact anything. Now I will explain why. See, if this is the case, then we will get the correct answer. Like if we subtract the sizes, then we will be left with this much portion. But if suppose the ranges are like this is the first range and this is the second range. If you even if you subtract them, um, then see, normally the answer that you would have gotten is either this range or this range. But because we assume this to be the maxima, I covered this in the second and third case, or we can assume this to be the minima. But if you subtract their two sizes, then like what will happen if you subtract them? Like the resultant will be less than the answer which would have been obtained by case 2 and 3. So the answer for this case 4 would have been less than the answer for case 2 or 3. And since we are taking the maximum, this would get ignored. These one of these two will be used. So that's why it doesn't really uh, matter. Like you don't really have to worry about the ranges. Also, suppose if the two ranges were not overlapping. This was ith range and this was the jth range. Even if you subtract their sizes, right? The answer from case 1 that you would have gotten previously would still have been greater than this. So again, this would have been not been considered in the final answer. So, but yeah, this case would now be included. So the fourth, so if there are segments like this which are fully overlapping, their contribution will be properly taken. Okay. Um, Now I will explain. I will show you my code. I did few small hacks, you can say. So suppose like ideally you should check for all of these four cases, but in certain cases you don't really need to check all four. Now why? Because suppose this is u and this is the next range. Like there is uh, there is some range which is uh, ahead, like which is disjoint with you and ahead of you. And suppose this is one case, and for this range only there is another. Let's there is another range which is partition, which is like intersecting with you. Then if you look at two, case two may we assume this to be the maxima and this to be the minima, and we basically looked at this range, right? But uh, by case 1, either this would have been the answer or this entire thing would have been the answer, both like the maximum of them, which would have been greater than this smaller region, obviously. So if something is a disjoint range, is like you don't really have to listen to this. You can just try to implement the previous four things, but because I'm going to show you my code, that's why I'm explaining. So if there exists a disjoint range to your right, then you don't really need to look at case 2. Okay. That can be ignored. However, case 3 still needs to be checked because uh, suppose this is u and there is a disjoint range to your right, but there is a very big intersecting range, like something like this. So obviously this answer you need to also compare with this. So in that case, case 3 you definitely have to check, and case 4 you can check. Like if there is if this situation is occurring, then you also don't need to check for case 4 because any fully overlapping range will obviously uh, give you a region like this plus this, which would definitely be less. Um, than the answer obtained by case 1. Okay. So basically you can ignore case 2 and 3 if you find a disjoint range to a right. Like if you find something like this, then you can ignore case 2 and case 4 you can ignore. Okay. So that's what I've done. Like if idx is not equal to -1, that means there is some disjoint range to a right. Then you just look at case 1. You compare like the maximum size on your right, and other is like you query for the maximum endpoint to your right in this range. Otherwise, um, then you need to like look at all the cases 1, 2, 3, and 4. Like you cannot look at case 1 because uh, there is no like idx is equal to -1, so there is no disjoint range. But then this is case 2, this is case 3, so maximum endpoint, and this is case 4. So your length minus the minimum um, length ahead of you. Okay, and finally you multiply everything by 2. So that's how you solve the problem. I hope you understand something. Thank you for watching. Bye bye.